Welcome to Welcome to CS46K Programming Language, Lecture 6, Class-to-Class Relationship. Today we are on Chapter 5B, the Part 2 of the Chapter 5, the Object-Oriented Programming Class-to-Class Relationship. The objective of today's topics will be the encapsulation, class-to-class relationship, inheritance polymorphism, interface, and abstract class. In fact, it will be on the duck typing, and then the duck function, and then will be functional closure. These are the topics related to the class-to-class relationship. Python does not have an interface, so duck typing and the function were used in lieu of interfaces. Understand what duck typing is and trying to use Python interface and function closure for advanced programming. So first topic is encapsulation. Information hiding by module. This one we discussed it in the previous chapter. So we already know that encapsulation is using the private data type and public method and to hide your data from the outside. And information hiding is provided by the module, so you can just use the interface to access the module. So the client access the control interface, and then inside your design, you have the algorithm, data structure, and the details of external interface, resource of allocation policy. These will be hidden from the outside, so client cannot see. Client can only see the control interface. This is called information hiding. And encapsulation is also related to information hiding. So it actually is talking about the enclosure of your data and methods. And we have different scope: your local scope, enclosing scope, global scope, and built-in scope. And this one so-called LEGB rule. So you check you are available by LEGB order. From local, and then enclosure, and then global, and then built-in level. Okay, this one is encapsulation. Encapsulation mechanism enable the programmer to group data and the subroutine that operate on them together. This one basically can be in a class or can be in a module. Either way, they will hide the information from the people. A data hiding mechanism or module in non-object-oriented programming language is considered to be one way to do information hiding. And the new data hiding issues in object-oriented programming that arise when we add in inheritance to module to make classes. So classes is a way to implement the information hiding or data hiding. A module as manager approach and show you how several languages, including Ada 95, Fortran 2003, and inheritance to records, and allowing module to continue to provide data hiding. And these are already old, so we will continue. And your outside code can only access the public method, and your private data and private method is hide from the outside code. So here one thing is the ID. The ID without underline, we call it public. So this one is you define available to be public if you don't put any underline there. One underline means protected. So protected, only your subclasses can use it. So like public member, but they should not be directly accessed from outside. Only your subclass can get it. Private one, you can private one, nobody can see it from outside. Only your same class can see it. So these are three levels in Python. And class member accessor. So private member accessed by own class, yes, yes, yes. Okay, accessed by derived class, protected and public are okay. And accessed by object, any accessed by outside, only public member can be accessed. So public attribute in Python, every member of the class is public by default if you don't use the underline. And public message in the class can be accessed from anywhere outside the class. You can access a public member by creating object of the class. Okay, this portion, we had different code. We had a music code, and you create a music, and you have a constructor. So there are two public data fields, genre and the singer. And you have the function that's also public. Okay, so you can actually access the two data field and the function, you get the result that you want. Okay, private attribute. So private attribute is underline before it. So here you can make the genre and singer. Okay, and then if you can use this one, you can use this obj underline function. Okay, so access a private member of the class. Okay, so obj is object. Here okay, let me see. Here you have full function, and full function you create an object. And here, let's see, your obj can run the full function. Okay, and the private data or private function, this one is a private function, can be run. So you create actually a object using this constructor, and then there are two private data field, and these two private data field can be accessed only by the function of its own class. So you call foo will be able to run the private function and to get in the data, but you cannot directly access them from outside. So private attributes in Python, if you try to access the private member outside the class, you will get an attribute error. Okay, that is an error. So here, if you try to get the function from outside, you cannot. Okay, you cannot. That's the problem. Okay, that's a problem. So here we do have a obj. Okay, let's see this obj. Let me get the code. Okay, let me get a code module. Okay, right here, let me actually open my folder in my sample code, chapters, lecture 6 sample code. Okay, so here we do have the music. So let's try music 2. So music 2 do have the obj. Okay, so obj is an object, and this one let's run it. Okay, so here, as you can see, you create an object. Okay, the object is using the constructor. So there are two data fields being created. Okay, being created, and then you have private function that's fun. Okay, there's a public function called foo, and public function can access the private data, and it accesses the obj. Okay, so obj is what? At this moment right here, it is a global variable. So the global variable, if you put outside, you cannot access, but if put inside the function, it will be able to get it. So here you have the obj, but obj is not self. You can call self, you can call the obj from outside. Obj from outside is global variable, so it's defined over here. Okay, let's try this way. Let's try to actually change this one to self. Okay, change this one to self. So obj is a object. So you call it self that function, and that one you get the same result. So here this self means the current object, that's the obj. But if you change it to obj is a global variable, and in this case it works, but in general it may not. You actually is access a outside function. So you are accessed by an outside object, and this one may be undefined. So if you don't call it obj, you call it obj1, then these three have no definition. So in this case, it won't work. So this one is only to show you that your OBJ is in the same class, so you can access their private data field if the function is defined in the class. Okay, that's only to show you that feature. Okay. Next one. Okay, next one we had the property and the food setter. This one we tell you before. Okay, this one we tell you before in the previous chapter for the declarator quotient. Okay, and class and object class relationship. Okay, so let's continue. Okay, that we talk about the visibility in the previous section. Okay, so now this one is classes and object and class relationship. So class abstraction and encapsulation. So you actually provide the interface so that the client classes can access the code through the interface. So we know about this. Next one, designing a class, coherence. So a class should describe a single entity, and all classes operations should be logically fit to support coherent purpose. And one mission for each class. Okay, this is very important, class coherence. So each class should have its own responsibility. Don't put too much responsibility in the class. This is so-called separating the responsibility. So right here, we are talking about the guideline for designing a class. Okay, so classes are designed for reuse. Okay, class defined for reuse. And you can have different combination and inheritance to make the class to be more useful or can be reused. Okay, so provide public no argument constructor or override the equals method. Okay, to string method. These are for Java, and in our Python, it will be providing the equal sign. Okay, underline EQ. Okay, or the underline str function or the toString function. These are important part of the designing a class. Okay, so this is a guideline of the class, make the class reusable and more modifiable. Okay, so general good guideline for building a good class is have a good user interface, usable interface, implementation objective. Okay, like efficient algorithm and convenient. So you should have some implementation objective to be achieved, and separation of implementation from interface. This is also called encapsulation, and then improve modifiability and maintainability for future versions to make it reusable, and try to decouple the relationship between two classes. Don't have too much data dependency among the classes, and can rework class inside and without changing the interface. So you try to keep the interface so outside when people try to use it, they don't feel like you change the code inside. Okay, so this is the better coherence, but reduce the coupling among the different classes. And each class should have one mission as the guideline for designing a good class. So higher coherence, lower coupling. And coupling means the dependency between the two classes. So if you design one class that must use the variable in the other class, that's called coupling. Okay, so completeness, each class should have be complete as possible to support all of the operation and the data requirement for each class. Okay, and make the class more convenient, user-friendly, API-oriented, and systematic, and try to be clear, no confusion or ambiguous interpretation, and be consistent. So if you have the equals function, it's just implement the equals function. You have underline equal, use underline equal. Don't get different name. Some language like Java, they do have size for array list, length variable for array, and length parenthesis function for the string. So in that case, actually, it's very confusing. Different function or different container have different type of the size measurement. So right here we have the class relationship. At this moment, that's actually stop right here. Let's actually look at some examples. So here, let's look at the class-to-class relationship. So your class-to-class relationship has a relationship and is a relationship. So we are going to cover this one later. Okay, before we go to here, let's actually look at some example. So now I'm going to go back to my previous demo code location. So go back to here. Okay, so right here, let's actually create some module. This module called rectangle. Okay, this rectangle.py, we should have a class, okay, rectangle. Let's use capital for class, okay. So rectangle class should have a constructor, so define, okay, underline init, okay, underline I, okay, and cell. This one should have two variables W and H, okay, and we want to make the constructor to have no argument constructor, so we put 2 0 there, and we have cell that we want to make the data available private, so we do use with, okay, equals W, okay, and cell that underline height equal H. This one I don't want to use underline with and then underline. I save them for system variables. Okay, so we got these two. Okay, then we can have the getter function. This one same thing. We can have a default value. Okay, so here we do have the getter setter done. Okay, getter setter function now done. Now let's actually define the equals function. Okay, we compare to other. Okay, this is checking if R is one instance of the rectangle or not. Okay, if not, we return false. Otherwise, we'll return okay. Okay. Okay, so this is the equal function. So that's the one that's actually put the toString function. Okay, we set these two, basically set these, this getter setter equals and toString function. We finish this different one, and we do have a private variable over here. Okay, so this one we try to make this one a class. Okay, this one a class. So let's try this one. Let's try to have one R1 equals rectangle. Okay, 3 and 4, and let's pull in my R1. Okay, this is a simple test. Okay, let's see. In our let's save. Okay, we may not have saved. Let's save it. Okay, it's rectangle 3, 4. So this one working. Okay, but in order to make this one useful for other class, we better set the testing call to the main function. So we actually ship this two. Okay, that's inside the main function. So here we can check if the underline name, okay, equals underline main function. So in case that it is this rectangle is not in the main module, then the rectangle, the main function will not be run. Okay. Okay. So right here, let's actually create another one called test rectangle. Okay, so this test rectangle.py we should actually from rectangle import let's rectangle import rectangle. Okay. And we can actually do the same thing here. Let's use this tool. Okay, RPD. Okay. So now let's change it to 30 and 40. Okay. Okay, so this one's a pure testing class. Okay, so you get this one. Okay, so that's the rectangle class. Okay, and you can define a square class that inherited this rectangle. Okay, so that is a relationship. Okay. Okay, so this one is a subclass for rectangle, but there's only one side. So we do define, okay, underline init. Okay, and here you have cell, and then you have one variable side, but we can set it to 0 using the default value of 0 if this it's not given, it's no argument constructor. Okay, so right here we actually would use the rectangle as our base class, so we do not need to use the width and height. Instead, we will call super. Okay, and then init. And then pass your side there. And size should be used for both width and height, so we call it this way. Okay. Get width, get height, we don't need them, but we can use a get side. Okay, this is get side. We will return. It's a subclass, so we cannot directly use a self that underline width. We cannot use that, so we will use get width. Okay, and then you actually should be get width. Okay. Now we can have a setter. Okay, in this case, we'll set cell a cell that set is a semicolon cell that set height s. Okay, this one finish the set side. So in the set side, get side, okay, we actually use this to equal, I think it's okay. toString, I'm going to override toString. Okay, so this one finish my two string function for square. So this one apparently you can see square inherited the rectangle. Okay, so here let's do this one. We have s1 equals square of pi. Okay, we do print. Okay, that's the self-tester. Okay, so that actually is pi. Okay. Okay, now we have rectangle. Okay, we can also put these two into my test rectangle. Okay. So square class is not imported. So right here you can put square, comma square. Okay, to import a square class. So here let's put 50. And you get this. Okay, and you get this. So this one is the class. Okay, the class. Okay, the subclass and class. Okay, so that actually gives us the idea of how to define a good class, including the constructor, getter, setter, and equals and to string function from the object class. Okay, made it to have good interface, coherent and complete and clear. Okay, these are the guidelines. Next one, I'm going to talk about the has a relationship and is a relationship. Okay. So we do have this one called rectangle and the square. Okay. Now let's actually create another one. This one called rect list. Okay, rectangle list. So we will create a rectangle list. Okay. So here we have a class. Okay. Let's use the has a relationship. Okay. So here we have a class called rect list. Okay. Rect list. So this rect list will have a constructor. Okay, and cell, and then list. Okay, we can have a rectangle list, and we can fit it into our construct, our function. So here we have cell that underline. This one should be data. Okay, equals the list. Okay, so list default would be a empty list. Okay, would be an empty list. This one has a relationship. Your rect list has one data field. Okay, so let's do this. We can do first one. We can do this one is a list. So we define the size. Okay, size of this one. It will be returning the length of cell underline data. Okay, and we can define is empty. Test return length of the cell that underline data. Okay, saying equals 0. Okay, that's empty. Then we can define get. Okay, we can get cell index. Okay, return cell underline data of the index. Okay, we can define set cell actually index. Okay, and then value. Okay, so we would do this. We would do if. Okay, index then 0. Okay, or index greater equals length of the cell. In this case, otherwise, value will be equals self dot underline data. Okay, index value will be bigger. Okay, and at the very end we return this R. That will be the value being replaced, and then with our self that underline data of the index will be equals value. Okay, this one is called setting. Okay, this one is called setting. So we have getter, setter. Now we have defined. Okay, we should have another one. This one called radius. Add. Okay, cell. Okay, index. Okay, and just value. Okay, just value. So just value. We will do this. We will do cell that underline data. Okay, append value. We can have define. Okay, add cell. Okay, index. Cell underline data. Insert. Okay, index. The value. So right here, as you can see, we are define some rectangle list. Okay, we'll define some rectangle list just like we are defining a list class. Okay. Okay, so we have editor. We will have another one called remove. Define remove. So, okay. So this one we will use similar structure to this. Okay. If the index is out of bound, then we return none. Okay. If not out of bound, then we will. Okay, we will actually do cell the data. We'll back up the data. Okay, and we'll do cell the data that up. Okay, index up. And then we'll return R. That's the remove function. Okay, that's the remove function. And so we have getter, setter. Okay, next one we will define. Okay, underline equals. Okay, function. Okay, of cell. Okay. So other. Otherwise, we return cell that underline data. Okay, this one is the equal function. Last one to string function. Cell. Okay. We'll do return str of my cell. Underline data. Okay, let's try this one. We have complete setting for my rectangle list, and this one is actually using a radius that actually include a list inside. So let's do this one. Okay, so let's do RL. Okay, will be equals rec list. Okay, on nothing. So here we put L. So let's do this one first. Okay, we have nothing and we try to run it. Okay, so it's an empty list. Okay, empty list. So right here, let's do this. Let's do. Okay, let's do this one. Okay. Try one more time. Okay, try one more time. Okay, that's a red list. Nothing there, but let's actually try to get this tester. Okay, let's try get these two tester. Okay, put over here. Okay. This one, let me change the name to this one. Okay. Okay. And here we have R1, so we don't print it. Okay. And we cannot see the rectangle and the square. Okay, we cannot see that. So here you need to do rectangle. Okay, import star. Okay, import every class. Okay, now we get that done, and then we do R list one that get R1. Okay, and R list one that add. Okay, S1, and we do print out my R list one. Okay, one more time. So let's see. Missing value. Okay, let's see. R list that add. Okay. So here we do have one function. Okay. So let's see here. Actually, we should. This one we do have duplicate function. So let's actually get this one. Let's actually do this one. Okay. So how about this? That actually do this. Okay. Let's do. We need to have index. So this index default value is 0. Okay. And value default value, let's also put 0. Okay. Let's also put default value 0. Okay. So here, let's see, we have add. So let's add actually add. Okay. So add value index. We had this two value. Okay, we had this two value, and then we had this two value, and we insert it to our list. Okay, and okay, let's do this. Okay, let's do this. This one, let's actually keep it as add. Okay, here and here we have append. Okay, so we can append and append it to certain value. So here, let's change it to append. Okay, and this one is add at 1. Okay. So this we have two object. Okay, two object, and then it actually print out the object type. Okay, so it convert the data to list. Okay, save that data. So this one is a list. Okay, it's a list, but it is not. It is not the. It's not going to calculate the two-string method. So this one we need to change a little bit. Okay, so here we have s equal empty one. Okay, we have this one, and then let's actually have the left side bracket. Okay, and at the end, s will plus equals the right side bracket. Okay, and then we will do this. Okay, we will do okay first equals true. Okay, and then actually for okay for x in cell that under the data. Okay, each data we get the x. So if first, okay, do this. If first we did this, we actually do s plus equal, okay, str of the cell of the x, okay, and then this one we do nothing. Okay, this we do nothing, and we say first equals false. Okay, we say first equal false. Otherwise, we do s plus equal. Okay, here we have comma space and plus str of the x. Okay, and this one right here, we actually convert it to s. Okay. Okay, you see, and the technical list now can be inserted. Okay, put it over there. we do have this one at 1. So we append R1, we have R1. We create this one. Let's see, one more time, okay, let's see. We have, let's see. Oh, okay. Here we should have else, okay. We should have else. Okay, else. So there is one more element being printed, okay. Let's try one more time, okay. So this one we have 2 elements in the rectangle list, okay. So roughly this one show you that I can create a rectangle list container using the has a relationship, okay, because I create my own list for it, okay. So this one is a red list. Let's try another one. Let's try rectangle list.py. This one, let's use the is a relationship, okay. So instead of using the has a relationship, this one, let's actually put it over here. This one is rectangle, okay, of the list, and here we do put the list, okay. We put a list as a, okay, we put a list, okay, we put a list, we put a list, okay, we put a list, okay. We put a list. That's our data type, okay, that's our data type. So here we can have an init, okay. We can have an init, but we do not need to have any init, okay. We do not need to have anything. So right here, let's just do pass. Okay, let's just do pass. So it will be a test, okay, and we will do pass. Okay, the only thing that we need to be careful would be the let's try. Okay, let's try. Let's actually try to get this everything, okay, and put into my rectangle list, okay, right here, okay. So this one's a tester function. So let's go back to here. This one we still need to have define main function, okay. So this one, if it is other module that use my red list, should still work, okay. So here if, okay, underline equals underline, okay, yeah. Okay, this one, make it like this, okay, and it work, okay. Now let me actually copy the whole thing to my rectangle list, okay. So this one I'm going to put this here, okay. So this one I'm going to call rectangle list, okay. Rectangle list, okay, that's it. And this one just do pass, okay, do nothing, just pass. And let's save all and let's run, okay. So there's no attribute called add, okay, there's no attribute called add. Let's see, there's no attribute called add, okay, this one let's do change the name because it's actually using the so-called list. So let's go back, okay, change the name of the function here, don't use add, let's use insert, okay, make it compatible, okay, make it compatible. So red list is using the has a relationship, okay, okay, red list is using has a relationship. A rectangle list is using is a relationship, okay. This one is save, oh, okay. Okay, so you actually do use this one, right? It actually also print this one. So that's not acceptable. That's not acceptable, so that actually don't use pass now. Okay, don't use pass now. So we will rewrite we actually inherit from list, but the list is not what doesn't have everything we want to have. So this to string function, we are going to redo it. Okay, we are going to redo it. So let's put it over here. We are going to override it. Okay, we override it. So this one, it is a list, so we do cell. Okay. Okay, that's it. Okay, so let's actually run it. Okay. So this one show you what is list. So let me actually change the name called rectangle list. Okay. Okay, rectangle list. So what happened is, okay, this rectangle list is, and the list is a relationship. Okay, so rectangle list take over whatever feature from the list. Okay, so as you can see, I just override the string function. Other than that, the append insert, okay, it's exactly the same as the list. Okay, so this one is a relationship. Rect list, on the other hand, has a relationship. So the rect list inside it do have a list inside the rect list. Okay, this is called has a relationship. So to develop the same rectangle list, we can use the has a relationship or is a relationship. So in this case, is a relationship is simpler. But because you already define it as a rectangle list, you already define it as a list type. So you will behave like a list and you cannot expand too much. But your rectangle list, you can expand more because you can add two lists or even have some parameter over there, okay? And that would that would work, okay, that would work. So here show you the difference between has a relationship and is a relationship, okay? And here is a summary for these different relationships. Okay, this chapter we are talking about a class-to-class relationship, okay? So passenger and airplane. Airplane has passenger, so that has a relationship, okay? So airplane has passenger. So this one we usually use, has a, we use a dash, 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 and then arrow. Okay, sometimes solid line with arrow, okay? That's called association relationship or has a relationship. So has a relationship, you have association and also aggregation and composite. Aggregation is one to many, okay. I'm sorry, library and book. Library has book, and library and book is library has many books, okay. And it can be one competition is one-to-one relationship, okay. So library has book, library has one book, okay. And fixed account and bank account, okay. So fixed account, bank account is one kind of fixed account. So that's is a relationship. Is a relationship is using solid line and white triangle head, okay. And sometimes if you have the interface, we call it impermanent or realized. Let's use a dash line, okay. So printer setup is one kind of printer, okay. So that actually is impermanent, okay, impermanent, but it's also one kind of relationship, okay. So this chart show you the different type of the has a or is a relationship, okay. Now let's talk about section 3, inheritance. So inheritance is the second important factor in the object-oriented programming. So inheritance is the ability to define a new class that is a modified version of an existing class. So this one is from Sync Java, okay? And this is very important. So basically, you have a older class and you modify it. So let's assume that A class is the older class, we call it base class. And then you have extension, we call it B class. So to do this, we already define a new class. Okay. And also because some of the property that A class has, B class also share it. So basically make some code reusable. Okay. And also better for class management in terms of the different class. We can manage the different class to group the different classes. Okay. And also build up the class to class relationships. So one class share the structure and behavior in one or more other classes for sharing, resource sharing. So inheritance define a kind of hierarchy among the classes in which a class inherits from one or more superclass. A subclass typically augment. So it's actually improved or redefine the existing structure and behavior of a superclass. And in Java, we only allow a single inheritance. So one class can only extend the other class. But here in Python, we do allow multiple inheritance. So C can inherit A and B at the same time. There's multiple inheritance. And the Java, you can only allow single inheritance, but Java provide mixed-in inheritance. So not only the class you can inherit, you can also implement some interfaces. So that's called mixed-in inheritance. And here, Python use the so-called multiple inheritance. They allow the multiple inheritance. So the inheritance scheme in these two languages are different. And C double-plus language is similar to Python way. So here we have cats and dog both inherit the memo, and it is single inheritance. And memo is superclass or base class or parent class. And dog is subclass, derived class, or child class. And then we have Labrador or poodle, and they are dogs. And we have Labradoodle, and it's multiple inheritance. Sorry, I don't know about this dog actually. And they actually inherit both of the Labrador and poodle. Okay, they actually, this dog actually inherit these two classes. So that's called multiple inheritance. So it allows single inheritance or multiple inheritance in Python. So base class and derived class. Okay, so base class may have some feature, and derived class take over its feature and may have extension, some extra property or data field. So here inheritance. So base class has two features and derived class may have three. So inheritance syntax. So basically you have a base class. Base class, you actually have a child class. Okay, so that's we have child class. And this child class C1 inherited object class. So put the base class inside the parentheses. If you don't put the parentheses and parameter, then that class will also inherit the object class. Okay, and here you have two functions and something like that. So C1 is the name of the subclass. Object is the name of the superclass. For multiple inheritance, superclass are declared as comma separate list. So stack is one kind of list. Okay, so stack is one kind of list, and we have the push and push function. Okay, and that. So this superclass may either be Python or user-defined class. Okay, you can use the built-in class. Okay, actually here say Python really mean built-in. Okay, so in our example, the rectangle list is also extend the list class. Okay. Okay, so they are push and pop function. you automatically get it from this class. Okay, but push function, actually this one, it override the push function for the list. Okay, so now in inheritance syntax, a subclass inherits all methods of its superclass, and a subclass can override, that's replace or augment methods of the superclass. So just define a method of the same name, and although not enforced by Python, keeping the same argument for the method is highly recommended. So usually you have the same name, same parameter list, and in the subclass we call it override. So it's same function name, same parameter, but subclass, different class. We call it the overriding of the function. Okay, and okay, these two examples. So this overriding the function. So we have a stack that is a list, and calculator is a stack. Okay, so kind of like this. So stack will take over all the function from list, and calculator take over all the function from stack, and stack take over from list. So calculator also get the same function from list. Okay. Okay, before we move into the mix-in or multiple inheritance, let's look at our rectangle class. So the rectangle class and the square class. So square class inherit the rectangle class, okay? And there's a constructor, and we use the super function to get the super class, that is the rectangle class, okay, to get a function. And then we override the string function, this get override, okay? And the side, sketch side and set side are two derived function for the square class. Now let's move on to this mixed-in multiple inheritance. So in Java, we call it mixed-in inheritance. In Python, we call it multiple inheritance. These two actually are slightly different. Mixed-in inheritance allows single inheritance on the class and allow multiple implementation of the interfaces. And in Python, we allow multiple class inheritance. And actually, class can mimic the function of an interface. So Python does not have abstract class, does not have the interface, but you can use a incomplete or past function as the abstract methods. Okay, as the abstract methods. Okay, Python multiple inheritance. So you have you can have one subclass that inherits feature 1 and 2 from the superclass on the left. And you can also inherit the feature 3 and 4 from the superclass on the right. And then it may own its own data field. Okay, that's a multiple inheritance. So Python supports multiple inheritance. This creates chances to have collision in the function name. Okay, because we do have the inheritance, then you may have the so-called name collision. Okay, because they merge the domain. In the class statement, replace a single superclass name with comma separate list of the superclass name. Okay, and then when looking up attribute, Python look for method resolution order. So method resolution order will solve the problem of whose function will be empowered. So you go left to right, depth first. Left to right, depth first means, okay, left to right, depth first. Let's look at this class, okay. So here we have this one, Labrador function. So left to right, depth first means I try this one. And if not, I go to this one, and then left to right. So depth first, I'll go dog first, and then go poodle, okay. So depth first, and then go breast. Okay, this one finish, then go breast. So 1, 2, 3, 4, 5, then 6. That's depth first and go breast later. Okay. That's the order of the depth first algorithm. Okay, so that's depth first. So let's look at an example. So right here, we do have 1, 2, 3, the depth first, and then left to right. Okay, and that actually is a so-called method resolution order. So classic method for resolution, and sometimes there is new style resolution. So you go A, B, C, and then D and E. This is not depth first. Okay, so we need to look at the order, MRO order, okay, and depth first means this one, okay. And when do we use the right one? We can check later, okay. So right here, we do have a class, okay, we do have an A class, and B class inherited it, okay, and then C class also inherited it, and then D class inherited the B class and C class, okay, and then we can turn on the who am I function to see D1's who am I. Okay, let's actually look at this one. This one called Python MRO. Okay, method resolution order. Okay, so let's look at that. So let me actually open the folder for chapter 6 simple code. Okay, so chapter 6 simple code. Let me open this one, and this one is called Python MRO.py. Okay, so Python MRO.py. Okay, this one. So this one, we only have A have function. Okay, so D don't have function. So now that's actually, if we open the D function, okay, we open the D function, and then this pass that's actually don't make it work. Okay, so we have D function and we try to run this D function. So we will get this, okay, and D, okay. And wrong A because you actually print wrong A, okay, wrong A. Here that's actually comment out this one, okay. Actually that's comment out is print wrong A, okay. So we actually run D class and it inherit the function. So the who am I actually defined in D1, okay. So let's actually run it. Okay, so I am D. Now let's assume that actually D don't have definition. And we do have B and C has a definition. For this, who am I? Okay, C who win it. Okay, so between B and C, let's see who win it. Okay, and you say I'm D, so it's wrong. Who am I? Okay, so I'm sorry. This one I need to open it as well. I need to comment it out as well. Okay. Sorry for that. So here, let's wrong it. Okay. Okay, I'm sorry. This class we need to keep the pass. Otherwise, we don't get the constructor. Okay, sorry. So that's wrong. This one. It actually have I and B. So between B and C, it actually called the B's version. Okay. So let's look at. Okay. Now let me close the B, and let's keep the A and C open. Okay. Let's keep A and C open. So B, we still need to keep the pass open. Okay. C, let's turn off the pass. Okay. Now we have A and C competing for the definition of who am I. So you say I'm a C. Okay, I'm a C. So this one is I am a C. I am a C means what? Means C take over A. So this one actually is, let's look at it. The older, so the so-called new style, we do use the new style. So Python 3 use this style. Okay. So you go press first and then go on the next level. Okay. That's the new style. That's the new style for Python 3. So when we do experiment, we can figure out what is the order. So next one we have this. Okay. This one we have this one. MRO under the new algorithm. Okay, we try different way to do it. I have already shown you. Here we do have MRO2. Okay, So we have construct, we have this one, and foo is a function for each one of them, okay? So here we do have D, okay, and we try to run foo. We try to run foo, then we will print D. We'll print D and we super D and cell. Super D and cell, okay? Let's look at what that it mean by super D and cell, okay? So here, super C, okay, super function, okay, super function. So let's look at what is super function, okay? So Python super function parameter. So Python super function, okay, and can have parameters. So Python super function, okay, Python super function. So sometimes two classes have some parameter name in common, okay? In this case, you cannot pop the key value pair to it, okay? So instead, you define base class which unlikely object, okay? So here, okay, so here we do have C, okay, so here we do have, when we call super, we have the E, okay, super we have E. So super we have E, and then when we print out MRO, okay, so X the name for each E dot MRO value. So E underline MRO, it will give you the MRO order, and that would be ECADB. ECADB, so we have ECADB. So A inherit base, B also inherit base, okay? C inherit A, D inherit B, and then E inherit C and D, okay? Okay, that's E, okay? Now the MRO order based on this would be ECA and then DB, okay? This one is separate, and then base, and then object. So E will inherit C, okay? And C inherit A, okay? And it is C and itself, okay? So run the C and itself init function, okay? That's a super, okay? So it will not go to other branch, okay? So know that, okay, base must be the class in MRO. So here that actually when we run the E10, so E10, so here this is MRO order, okay? So here, let's see, this one differs, but this one actually is Python 2 format. Okay, this one is Python 2 format. So here we do have this one, okay? We do have this one, that's an MRO order. Okay, that's actually look at MRO number 2, okay? So this one we do have this, okay? So how about this one? Right here, we do have this, okay? And let's do point, okay? That, okay, underline MRO, okay, MRO. Okay, this one must be cut, okay. I'm sorry, put it over here, okay. And we use the class E, okay, to print out E's MRO. Let's see. That one, we do have, that E is a class, okay. Okay, so we do print out X underline name, okay. So we need to do this, okay. For X in, okay, that underline MRO, right, okay. So E is outside D, okay, D is a class, okay, D is a class. Okay, and we do print now X, okay. X is actually a class, okay. So this MRO class we print now in this structure, okay. Okay. no such attribute as MRO. Let me see. Oh, lowercase, I'm sorry. Okay, lowercase. Okay, so lowercase, you do print out D, B, C, and then A, and then object. So it actually is following the so-called new style because we are running Python 3. Okay, we're running Python 3.6 on my computer. Okay. Okay, that's the MRO order, how to get the MRO order. Okay, so you can check it. Okay, you can check it. So next one, class diagram. Class diagram are visual representation of relationship among classes. It's similar in speed of entity relationship diagram in the so-called Unified Modeling Language, UML, etc. In that, they help implement in understanding and documenting application and library architecture. They are useful when they are more classes and attributes. Okay, so that's that. So this one we do have airport. We have flying plane and ground plane. So airport has a flying plane. Okay, has a, and ground plane inherit plane. Flying plane also inherit plane. Okay, and flying plane has passenger and has employee, and passenger and employee both inherit the human. Okay, so this one we show you before. We do have the use relationship, has a relationship, own relationship. Okay, has an own relationship that actually is one to many and many to one problem. Okay, composition is one to one. So basically, B owns A. Okay, B owns A, and actually, this one B has many A. Okay, so right here B inherit A. Okay, and this one dash line is implement relationship or real line relationship. So that's for interface. Okay, that's for interface. Okay, so here we do see this one. We showed you before. Okay, and you will follow the Python 3's order. Okay, next one, super function. So super function is built in to return a proxy object that allow you to refer to as the parent class. So you will return parent class. Okay, in Python, super built in two major use. Okay, allow us to avoid base class implicitly. Okay, and work with multiple inheritance. So super will source all the multiple inheritance point. Okay, so right here we have memo, that is a constructor, and then doc inherit the memo. So we do in here. Okay, we do init. So doc, when you run doc, it will run the super init doc. Okay, so here is super init doc. So super function that is memo's constructor, you pass the doc in there, and the print out what you will print out doc for leg first. Okay, when you use a doc constructor, and then you will call the superclass constructor, and you will say dog is warm-blooded animal. Okay, so this one different from the Python that Python requires the super statement always on the first line of your constructor. But here we do not need that. Okay, we do not need that order. So super is to replace the class name. Okay, so this one like that. Okay, and okay. So here we actually, in the function, you need to put yourself into there, okay, and it will do this. So this one will replace that, okay, be a little bit easier. Okay. Okay, so class dog, okay, Canidae family, okay, Canidae family, and then there's a init cell print dog has 4 legs, and you super init dog, okay. So I'll call the superclass, that's this Canidae family. Okay, that's dog family. A family is one of the animal kingdoms level. Okay, Okay, single inheritance. So super built-in return a process object and substitute object has the ability to call measure of the base class via the delegate. Okay, this is called indirection. Okay, since this integration is computed at the runtime, we can point different base class at different time if we need to do that. Okay, if we need to do that. So here we have super M function. Okay, super function for multiple inheritance. Let's look at the super M function. So super M function, super M function. So here, let's see, let's look at it, okay? So dog inherited this non-marine mammal and the non-weak mammal, okay? So when dog call it, you call it constructor, and then you will print out dog has 4 legs, and then you will try to call the superclass, but it has 2 superclass, non-marine mammal and non-weak mammal, okay? And you print out this one and this one first, and then they will call the superclass. Okay, the superclass, and the superclass would be mammal. Okay, will be mammal for both cases. It will be mammal, and mammal is one kind of animal. Okay, okay, let's actually run this one. Okay, so it first run don't have 4 legs, and then it call non-marine mammals function. So you say it can swim, okay? It can swim, okay? And that one, we do have a perimeter. And that perimeter is what? Non-marine, this one. Okay, so you call dog. So this one being passed to there, okay? It becomes the constructor's perimeter, okay? You need to pass that. So you say dog. And then here, again, you call this one, and you pass the dog to here. So dog can swim, contain fly. And then this one you will actually call the this both of them call the memo. So you will call only once. You call only once for the I am one body animal and then animal. Okay. Then next one you actually call this one non-marine mammal pet. Okay, so non-marine mammal pet, it actually is creating this marine mammal pet. Okay, so starting from here. So you say pet can swim, and you go to here, pass the pet to the non-marine mammal, the parent class, that's a mammal. So you will say it's a warm-blooded animal, and then go up. Okay, so that pet can swim, warm-blooded, and come to here. And at the end, you print out dog's MRO order. Dog MRO will be dog, okay, non-marine mammals, non-wing mammals, and then mammal, and then animal. Okay, that's the order of the MRO. And this is new style. It go from button, there first, and then left to right, and then next level. Okay. Instead of going up first. And that's in Python 2. Okay, that's in Python 2. Okay, this is the structure of the different classes in the previous example. Okay, so this is called MRO, measure resolution order. Okay, and they go by this order. And then MRO calculate in Python. A measure is derived call, always call before the measure of the base class. Okay, you will call it first. Constructor, it will run according to the order of MRO. Okay, the order of MRO, and you by the superclasses order. Okay, by superclasses order. And you can put the superclass in the first line, then you will call the super's constructor first, okay? And we'll pass one level up first, okay? And then if you call a function, there's only one function will be called, okay? Only one function will be called in the different constructors. So here, when we have multiple call, we have a multiple call for a constructor, we will only call it once at the memo, because both the no-wing memo and the non-marine memo, they both inherit the memo. Okay, but it will only be called once. Okay, it will only be called once. Next one is Python command line input and the arguments. Okay, this one also useful in C double plus language or C language. Okay, when you have command line input and you can deal with it. Okay, so your Python test.py argument 1, 2, 3. Okay, so these are the system.argument vectors. Okay, that's available for system.argument. The number of vector is this. Okay, in C language we have main function, and we have integer, argument, count, comma, okay, character, array of characters, and then argument vectors. Okay, something like this. So this argument count is the length of this system argument vector. Okay, and this argument vector is this one. So it is argument 1, 2, 3. Okay, an array of 3 strings. Okay, an array of 3 strings. So argument vector will be passed to your program by system arguments. Okay. Argument vector. Argument vector is the squeeze name. So argument 0 will be test.py. Okay. Okay, so here we do look into this one. We print out how many arguments, okay, and then arguments. And then we can print out a string, okay, system that argument vector, that would be a list. So here we do Python command line 1.py abcde, abcde, and also this command line.py. So there are totally 6 arguments. And then the argument vector 0 will be this one, command line 1.py, and 1, 2, 3, 4, 5. Okay, that's the command line. Okay, and you can also define a main function with argument counter and argument vector. Okay, and you calculate these 2 values, put into your main function. Okay, you can also do that. That's mimicking your C function. Okay, that mimicking your C function. And then passing command line. Okay, sometimes you not only have the parameter arguments, but also have options. Okay, option is used for dash line. So here we will look into there's a function called get option, argument option. Okay, this thing. This thing is for C language. Okay, so there's a get argument console. So here, okay, here we do have the C language interface. Okay, so C language interface. So C language we have while loop, and then we get the argument counter and the argument vector. Okay, and we have SH, F, P, M, B. Okay, these are different options. Okay, these are different options. So option S and option H. Okay, they will get something from outside. And then there is option F, option P, okay, and then option M and option B, okay. So let's see. So for those without column, for those without column, we have S, okay. S will be suppressed equals 1, okay. And you can set some condition, okay. So here we have username Ben Hammer, okay, and then we have dash S. So S without column, it has no, it only is an option, but there is no parameter to be passed in, okay. And if you have a column, this H has the size, okay. F also has a size, and P has the num, okay. P has a num. So these are the way they'll take the second value, okay. So when you call it, you do call this one called Ben Hammer, okay, and then this S, okay, there is no parameter, okay, this H, and then maybe 35, okay, and that 35 will be passed to here, okay, and changing from characters to number, okay, to numbers. And if it actually return -1, okay, then what? Then it will what? It means that it doesn't find, okay, it doesn't find any arguments. Okay, so you process one by one, okay, to finish all of the arguments. Okay, this one's a detailed get up method. Okay, that's from get up module and get up method. And here we can import the system, comma, and get up. Okay, so here you will get in the argument from 1 to the end. Okay, these are tail of the console arguments. Okay, and you get that argument vectors. Okay, and pass it to argument vectors, and you have in file, out file. Okay, and then you get argument, and then it actually is -h -I with some number input file name, and -O for output file name. Okay, and -h, when you have a -h, okay, option is -h, you will print out help, okay, help message, and your program get out, okay, system.exit. Otherwise, you will do option, you get option is in this one is -I or -I file, okay, then the value follow the -I will be the argument, okay, will be the argument, and then it will be your input file, and the one following -O will be your parameter. So here you go through different option and the argument. Option is -I. Argument will be the file name following -I. Okay, this one is the use of get operand option for the main function. Okay, in Python. Okay, in Python. So right here we run the program. So we do Python test option.py -h. So -h you print out the help message. Okay, and then we do have Python test option and -I file aa.py -out file bb.py. So this one will be the input file name and output file name. Okay, and the next one we do -I a.py. Okay, -I bb.py. That is input name and file output file name. Okay, so that's that. Okay, this one similar. Okay. Okay, so that's option 2. Okay, finish that. So next one is magic variables. Okay, magic variable is also called grouping of a variable. Okay, so grouping of variable, you will group in all of the arguments from your function, and then make it a list if you use the arguments. Okay, and if you do key value, okay, keyword argument, you use double star. That actually would make the dictionary. Okay, so that one is very simple. So here, let's actually do this. Okay, let's go back to this one. Let me actually change the folder. Okay, go to my demo folder. Okay, go to the demo folder. So here, let's look at the demo folder. So inside the demo folder, let me create the so-called grouping. Okay, grouping arguments. Okay. Okay, this grouping argument. So here I have a function, f function. Okay, and I do say args grouping the arguments. Okay, and then print the type of your args. Okay, and then print. Okay, and we print the list of the arguments. Okay, and we finish that, and we do call f of what actually. 1, 2, 3, 4, 3, 4, 4, 5, 6. Okay, so let's just do this one. So we do this one and we run it. So apparently it is a tuple. So the arguments is a tuple. So this whole thing is 5 variable, but they will be grouped into a tuple. Okay, they will be grouped in the tuple, but I convert the tuple to array. Okay, next one, let's try another one. It's called G function. So G function has star keywords arguments. Okay. So these are KW arguments. Okay. Keyword arguments. Keyword argument. So this one is proving, okay, the type of the keyword arguments. Okay. Keyword arguments. Okay, and we actually print the keyword arguments. Okay, and this one we do G function. We do A equals 1, B equals 2, C equals 3. Okay, something like that. And this assignment of the value, parameter value, will become a dictionary, and A data field is 1, B data field 2, C data field 3. So that actually is the dictionary. That actually is a dictionary. Okay, that is a dictionary. And with that dictionary, we can also pass the parameter back to the system. Okay, so it's a grouping of the variables and grouping of the variable into dictionary. Okay, so right here we have magic variable 1. So when we call test variable argument, this. Okay, the first one will be FARG. That will be this one. It will be printed this way. Okay, the other 3 will be grouped into ARG argument vectors. Okay, that's that. So when we have the normal argument and grouping of the argument, the first one will be put into the first argument. The others will be grouping into the argument vector. Okay, something like that. Okay, so here we have a single argument. Grouping argument. We can print out the tuples length. Okay, we can also print out its 0 location. Okay, setting it to the maximum value, and then we try to find the maximum value among all the parameters. And by doing this, we will be able to calculate the maximum value for the different number of the parameters. Okay, so we make the maximum number function to have flexible parameters list. Okay, and this one KW argument is a keyword argument. Okay, keyworded arguments, and we do create this one as a key value pair, and the key value pair will be the keyword argument dictionaries items. Okay, and you print them out. Okay, so that's the keyword and value. So that becomes a dictionary. Okay, that one is not hard to understand. Okay, so here we actually skip a few examples. Just remember this one. These are different grouping way. Okay, grouping to list and grouping into dictionary. Details. Let's actually continue this one. Okay. Okay, details. So how super function is used? Okay, super function is somewhat versatile and can be used in a few ways. Okay, number one way is can be called in a single inheritance in order to refer to the parent class. Okay, or multiple classes without explicitly naming them. Okay, it's somewhat a shortcut. Okay, but more importantly, it keeps your code maintainable in a more real seeable feature. Okay. And if the same superclass being called twice, it will only be run once. Okay, so super can be called upon dynamic execution environment for multiple or collaborative inheritance. This use is considered exclusive to Python. Okay, it's not possible with language that support single inheritance or statically compiled. Okay, because Python is dynamically compiled. And the great things about super is that it can be used to enhance any module method. Plus, there's no need to know detail about base class. Okay, so we can only try it. Okay. Okay, so super, you can call some function. You can use super list to call some function. Okay, and here you can also put some parameter name. So subclass, okay, subclass, use MRO to find the superclass of this subclass. So when we have E, okay, and it will call the superclass using the MRO of this E classes superclass to find the proper superclass, and then run the method defined in the superclass. Okay. So that's a parameter that we talk about. That's the one that we've seen. That's the one we've seen before. We have seen before. Okay, that's the one that we have seen here. Okay, in the super, here, okay. In the MRO2, okay, Python MRO2. Okay, this one, no. Yeah, this one with super D. So super D will find the full function defined in the superclass of the D, and you use the MRO way to find it. So you'll find B first and then C, okay, to define which one would be the super, would be the definition for full function, okay. Okay, dynamic function. So super function is in business of delegating method call to some class in the instance ancestor tree by MRO order. Okay, the reorderable method call to work. Okay, the class need to be designed cooperatively. Okay, and usually don't make this one too complicated. Okay. Otherwise, you will find a hard time to figure out which one will be called. Okay, so binding with proper positional argument is okay, and then binding with flexible argument. You can use keyword dictionary or the keyword list. Okay, so that is okay. Abstract method. Abstract method is unimplemented method. Okay, unimplemented method. And in fact, Python do not have abstract method, okay? Do not have an abstract method. So we can basically use a pass function, do nothing function as abstract method, okay? So we can use that, okay? And in interface can be a abstract method with only abstract methods. Okay, abstract classes is only actually, so abstract class can have data field and some concrete method and some abstract method. Okay, these are terminology in Java. In Python, we actually just implement a class that has data field, has methods, and some incomplete method. We can call it abstract methods. Okay, but in fact, those should be some function that we just pass it and do not return anything. Okay. And that actually can always be overridden. Okay. Okay, so that's abstract class functions. Okay, so okay, whatever. This one's okay. This one's okay. So just you can use this one and just put it past, and you can declare this method as abstract method. And when you declare the abstract method, then its subclass will it's passed. It passed when actually here it doesn't have the so-called definition, and its subclass will have to implement it. Okay, its subclass will have to implement it. So we can make using this decorator to define the abstract methods. Okay. Okay, so inherit the abstract methods, and the concrete method inherit the custom defined abstract method. Okay. And abstract method without database is called an interface. Okay, so these are actually Python's way to mimic the abstract class and also the interfaces. Okay. Section 10, polymorphism. Polymorphism is the third important factor in object-oriented programming, and function that can work with several types, we call it polymorphic. So here it really means the polymorphic methods. But in fact, polymorphism, we may have polymorphic container, polymorphic method, and polymorphic iterators. So there are three different types of the polymorphism, and method is one of them. So the primary usage of the polymorphism in industry is ability of the object belonging to different type can respond to method, field, property code of the same name, each according to appropriate type-specific behavior. So the programmer does not have to know exactly the exact type of object in advance. So the exact behavior is determined at the runtime. We call it late binding or dynamic binding. Okay, so polymorphism in general has these four different types: overloading, overriding type, coercion polymorphism, inclusion polymorphism, and parametric polymorphism. The parametric polymorphism in Java, we have a list of some type. Okay, you can put integer or string over there. That's called polymorphism, parametric polymorphism. But because Python have no type, so we don't need to have this parametric polymorphism. Every function and every container in Python automatically has a polymorphic parametric polymorphism. And inclusion polymorphism, we already talked about it. Everybody is under object, and there's no type declaration. So this one do have in by default. Coercion, there's no need to do casting in Python, so we also don't need it. And then overloading, overriding is supported. So basically, we support this. And overloading, overriding is actually very tricky. So let's look at it. So basically, Python does not have the need for coercion and parametric polymorphism. And default has the inclusion polymorphism. And Python also accepts overloading polymorphism. So generic container, we have everything is generic. Tuple list are generic, so it's okay. Python methods are also generic. And okay, so parameter also generic. So this actually have no issue for Python at all. So now let's look at the polymorphism for polymorphic method. Let's first look at the brute Java program. So let's talk about the overloading polymorphism. Okay, let me put it into demo code as well. So here we have demo chapter 6. Let's pick this one, and let's have one project called Java. Okay, polymorphism. Okay, right here, let's actually create a class for methods. Okay, so methods. So polymorphic methods. Okay, in Java, let's actually look at some polymorphic methods. So we may have a method called public, okay, static, okay, integer maximum, okay. We take integer x and integer y, okay. And this one can take 2 parameters, and then we will return, okay, we will return here, we will return, and then actually x greater than y. Okay, we use the conditional statement. So if x greater than y, we return x. This is a maximum, okay, for the integer parameter. And now, if we change it to double type, okay, we change it to double type, same variable, and we need to write it twice. Okay, so here we have double type. Okay, for x and y. So these are considered overloaded. Okay, these are considered overloaded. Now let's look at this. So overloaded may be because of the type, and it may also because of the number of parameters. So here let's try another one that has more parameters. So here let's go back to integer. So integer x, integer y, and integer z. Okay, and here we use integer. So here we do have integer. Okay, so now we have a integer m equals, okay, this guy. Okay, let's actually do copy this guy, put it over here. Okay, and then we should have m and g. Okay, and m, otherwise it will be g. So this one actually is 3-parameter maxima function, and then we have 2-parameter maxima function, and we have 3-parameter maxima function. So let's have a function public static, okay, void name, and then string, divide bracket args, and then we have this. And that's do system.out.print. I print out our maximum of the 5 and 4, okay, and then let's copy this one and put it over here. Let's have 3.0 and 7.0, and then that actually put one more. So there we have maximum of 2 and 5. So this actually 3 maximum function call, it do run different version, and we get the result. Okay, we get a result. But in Python, okay, in Python, let's actually go back to our folder for demo code. So in here, let's actually look at here. So we have a polymorphism. So let's actually create one file called poly1.python. So right here, let's define a function for maximum. And we are going to take in several number of the parameters. So we do this. Okay, we do this. So we have x and y, and then here we actually will do star arguments. Okay, star arguments. So we have a grouping of the star arguments. Okay, so here let's do this. Okay, we actually let's do this one. We can have a x and y and star arguments. Okay, so let's look at this function. If, okay, the length of the args, okay, equals 0, okay, so there is no extra parameter other than x and y. Okay, and this one we should return, okay, actually x, okay, if x greater than y, else we return y, the conditional statement. Okay, so this one, if the argument is 0, okay, otherwise we will declare a maximum that is equals this one. We will have a maximum that is this one, and then we will have for each g in the arguments. Okay, and then we will do the maximum will be equals the this thing. Let's actually copy one more time. We'll return z if g greater than the m, otherwise we'll return m. So this one we find the new maximum, and this one we return the maximum in m. Okay, this one is a function that we do have 2 parameters and possibly 3 or more parameters. So let's actually look at this polymorphic method. So we can print the maximum of, okay, let's actually copy this program from the Java program here. So let's copy this 3, okay, copy it over, and then let's put it over here. So let's do paste, and this is Java format. So let's cut. Okay, and let's cut this portion. Let's cut this portion. Okay, let's cut this portion. And let's cut this portion. Okay, so these three program is calling in the same way as the Java code, but we do use the Python code with the grouping of the parameters over here. Okay, so the grouping of the parameter is like this, and let's run it. Okay, and we do get the same result. So right here, it do show you this method, polymorphic method. It not only solving the problem of the overloading of the different data type in the parameter, but also solving the problem of the different parameter lengths. Okay, by default, at least we do need to have two parameters in order to calculate the maximum amount between this x and y. So maximum number of parameters needed will be at least two, but it can be 2, 3, 4, 5, or any arbitrary number that's greater than 2. So that's the polymorphic method that is in this chapter here. So the way we do polymorphic method is totally different from in Java. Java, we do need to use the data type, the object type, and then use the object type and do a lot of casting in order to achieve it. Right here, we do not need it. We do not need that thing. And we also can have polymorphic classes, okay? So polymorphic function, that's a polymorphic method. Polymorphic classes means polymorphic container. And this one actually like list, those are polymorphic containers, so we do not need to discuss this here. So the critical feature of polymorphism is a shared interface. Using the Darnley definition, we present a common interface where the same function may be used regardless of the argument type and argument count. Using the Wikipedia definition, we require the polymorphic object to share a common interface that to use. Okay, common interface means that you have an object, so there the function name should be the same. So that is the polymorphic methods. Okay, so why polymorphism is useful? By using the same interface for multiple purposes, polymorphism reduces the number of things we have to remember. Okay, and it's generic. So Python by default support the generic programming much better than the Java language. To define polymorphic function that accept multiple type of data that require the function either be able to distinguish among the different types that it should handle, or be able to use other polymorphic method, functions, or syntax to manipulate any of the given type. Okay, this portion I just read it through and it's okay, not too hard. So polymorphic method type-based dispatch. Okay, so we have instance function has attribute function and class attribute. Python provides several ways of identifying data type. So you can use its instance of function, its function has attribute function or class attribute to find out which class it is. So these are the mechanisms that you can use to identify the data type. And by using data type, you should be able to differentiate these different types. So right here, we have a class, okay, NC, okay, and then it inherited object type, and we pass. And there is an OC and the type, okay, that also have no content. And then there's a function. What is this data being passed? So we can pass a string over there. Okay, that's a data. And we actually use it in instance and checking for string type. And if it is string, you return it. So this one, you return it. Okay, and then we check 12, and 12 is will have attribute class. Okay, and you would print out the class name. Okay, and then error type. So here we do run this one. We can run this one. Okay, this one is in dispatch.py. Okay, Python. Okay, let's look at it. Okay. So right here, let me bring up my chapter 6 one more time. So let me save. Let me open my chapter 6 demo code one more time. I'm sorry, lecture 6. Okay, not chapter 6, lecture 6. Chapter 5b, but lecture 6. So here we need to look at the dispatch here, the py. Okay, so this one, let's run it. Okay, let's run it. Okay, let's see where it is. Okay, where is the output? Let me save one more time and let's run it one more time. Okay, let's run call. Okay, so that's the result is over here. So the hello is a string. Okay, let's see, let me move up a little bit. So hello is a string, 12 is an integer, this one is a list, and this one 12 and 14, that's a dictionary. And this is NC type, this is OC type. Okay, so that will print out the class name correctly. Okay. Okay, that actually will print out the class name correctly. Now next one. So this polymorphic syntax. Okay, Python use the same syntax for a number of the data types. So we can implement polymorphic method for this data type if we use the right syntax. Python data type are all subclasses of the object. Therefore, it is considered to be polymorphic by the language itself. Okay. And then we have this one called histogram. So histogram, we create a dictionary, and then we, for each C in S, so S maybe is a string, so it's a string, and then we actually add the data into the dictionary. Okay, add the data in the dictionary. And we increase the number of the data by count. So if it's 0, the dictionary, we get the number, okay, and then the counter, okay, the data, okay, we will actually +1 to increase the frequency of that data, okay. So by doing this, we can get the so-called histogram, okay, we can get a so-called histogram. So let's look at the code and run it, okay. So this one is the so-called histogram. So histogram is right here, okay. So basically, dictionary has a get, okay, C and comma 0, okay. So let's look at the get C comma 0. What's that? Okay. So Python, okay, dictionary get, okay. Python dictionary has a get method, and this get method, okay, if we get model, the model would have a value, okay, and that would be the master, okay, the master. So that's that. And okay, the use is a get function, but we can have the key and value, okay. Value is optional. When the value is returned, if the specific does not exist, those data doesn't exist, you will provide 0. So 0 will be returned when it actually doesn't get it. So this one, when there is no C in the dictionary, it will return 0. So remember this format, okay, it's very important. And let's run this one. So we get this, okay, that's the histogram. Let's continue. So next one. Polymorphic classes. So polymorphic classes are the classes that actually had the same function, okay, same function. So although Python does not require it, but it's a simple way to achieve this is to have the classes derived from a common superclass. So if you have common superclass, then those functions will have definition. So you will have the same function. So that would be better. Python consider polymorphic class do not have to be under the same class. Okay, but Java will require this. This is an inclusion polymorphism. But Python, because everybody inherited from the object, so it actually should be fine. Okay, as long as you put the function name of the same name, the common interface, it should be fine. So this one, more or less, is the so-called practice of the coding standard. Okay, and polymorphic classes, the superclasses define the interface. Okay, and we call it abstract base class. An abstract base class can have the basic have abstract methods, okay, and then the subclasses can just use it. Okay, the subclasses can just use it. That's this one actually. Okay, so subclasses of the abstract base class override the interface method to provide class specific behavior. Okay, to provide class specific behavior. All generic function can manipulate all subclasses of the object class. Okay, so series.py. So let's look at this one. So series.py. Let's actually look at the series.py. So series.py. Okay, over here. So there is a infinity series. Okay, there is a Fibonacci. There is a geometrical object. So Fibonacci is one subclass for the infinite series. Geometric series is also one of them. Okay, and then we have a function called print series. Okay, and print series we have S, and we will print now the first 10 elements. Okay, in the series. So we print series for Fibonacci and this different one. So these are, we have different classes over here, okay? But everybody provide the next function, okay? Provide the next function. Okay, so that's a generic polymorphic method. Okay, let's run it, okay? Okay, so this one is Fibonacci number geometric 6 series, and then infinite series. Okay, so this one show you the function name is the same. So when you run this different one, okay, you do print a series. Everybody has a next function that you can call, and that okay will actually be a good example of implementing the polymorphic method. And these three we call them polymorphic classes. Okay, and then in development of your classes, you need to consider the inheritance structure and then see which one of them need to implement the polymorphism. Okay, so here we have hand, poker hand, and deck. Okay, and poker hand and deck and poker and game. These are different. Okay, these are different inheritance tree. Okay. Okay, so it's more complex better. Okay, actually, more complex things will not be better. Okay, more classes means that more things to remember. Okay, and need multiple interfaces. So, but the advantage of more complicated, each class corresponds to a real concept. Okay, so more specific in a way. It should be possible to write a polymorphism to play cards only game and hand interface. So here you can write left hand side. This is one inheritance tree you can use, or you can write this one. Okay, but do you want to be more complicated or more simple? It's up to you. Okay, and introspection. Introspection is in everyday life. Introspection is self-examination. So introspection refers to the examination of one's own thought, feeling, motivation, and action. So here in object-oriented programming, the introspection means that the inspect of the data field and the internal scene, internal data structure. So we have system.platform, system.version. These are different parameters you can use. System.argument, system.path, system.module, and system.max size. Okay. Okay, and then we can look at this show system numbers. So these are one introspection. Okay, introspection. So we import a system and we put now these different parameters. Okay, these different parameters. So the platform is Windows 32, okay, version, Python's version, okay, and maximum size is this much, okay, and then the argument list and pass, and also the modules, okay, current module that it should be included. Okay, so that is introspection. And each object or class, we can use the dir to inspect its content. Okay, we can use dir to inspect its content. Okay. And then you can dir some keyword, dir sys, okay, or so dir is a built-in function. You can inspect a lot of things. Okay, this one we don't rock. Okay, it's okay. You can just try. Okay, so you can also use it in debugging mode. Okay, so this one I just kind of skip it. Duck typing. Okay, duck typing is an automatic interface. So duck typing is a feature that a type system where semantic of a class is determined by its ability to some message. So duck typing in the Java, we are using the interface. Okay, so interface enforces some classes that will have to share the same function. Okay, but in Python, because there's no type checking. Okay, no type declaration. So you can just define something that has sharing some function. So if it look like a duck, swim like a duck, and quack like a duck, then it probably a duck. This is the so-called duck typing. Okay, so duck typing needs to be implemented by type inference. Okay, or type propagation. So polymorphic method, goose and duck create two objects of different type. They share the common polymorphic method, and Python does not require the type declaration. The object type is assigned at the runtime. So here we have a duck, the quack, goose also quack. So goose, we can create a goose object and quack, and duck object and quack. Okay, so they will quack in different way. But this is a polymorphic method using duck typing. Okay, interface. Okay, interface is a reference which represent object of different types. But Python do not need it because Python has no type definition. So Python will automatically have this interface. Generic method, we talked about it already. Okay, so that's, you can, that's here we do have the Java interface. Okay, Java interface, iEngine, so that will enforce turn on function. So if your engine implement iEngine, you have to implement that one. Okay, so you have to have the turn on function. Okay, Python class, there's no need to declare interface, just define polymorphic method. Okay, all the duck typing. Okay, that's it. That's all you need to do in Java. So Java in Python. So Python somehow is easier than the Java if you compare the number of line of the code. Okay, so duck typing, you have the duck that quack and fly. Okay, person also quack and fly. So in the forest, so something, this thing will quack and fly. Okay, no matter it's a person or it's a duck, they both quack and both fly. Okay, but they may quack and fly in different way. This we call it polymorphic method. Okay, it's two polymorphic method, and then this in the forest can deal with two different data types. We call it generic method, but this generic method can only be used for data types that have the quack and fly functions. Okay, otherwise you would have problem. Okay, this one is okay, and this one, okay, you can check. Okay, Python type. Python do dynamic typing, so it is the type is determined at the runtime. It's a dynamically typed language. Okay, Java is static type. Python is a weak type. Okay, Java is strong type. Okay. Weak type means that the type is not, typing rule is not strongly enforced, but Java do have the strong enforced type. Okay. Okay, so here we do see Java is a strong type language, okay, and then it's also static type. Python is a strong type, near weaker type, but it actually is dynamic typing language. Okay, in a statical type language such as Java, okay, every variable name is bound to both. Okay, so we do have a type. Okay, okay, okay. So let's see, it's okay. In dynamic type language, every variable is bound only to an object. Okay, so type bound to an object. And this one type can bound to class because at the compile time, they already know it. Okay, Python variable can be assigned with value of different type. Okay, this is okay. You can assign in the wrong time the different type of data to a same variable. Okay, this one, okay. Okay, so length function is a polymorphic measure. You can check the length of this one for string or this one, okay, and this one is an integer. It doesn't have a length, so you will raise a exception. Okay, use of duck typing. So here, use of duck typing. Declare a global variable that assign the value of different type data. Okay, polymorphic measure, generic container. These are different type of the there's different situation that you can use duck typing. Okay, because it's similar to the interface, so I do not emphasize too much on there. Okay, but duck typing affect the way we write functions. So we have full of xy and x will duck bar y times 2. Okay, and what is x, what is y, and how x bar y? Okay, it depends on the data type of the x. Okay, the bar function can be totally differently. Okay, so this one we call it type inference. Okay, so the type of the signature, functional signature, we don't know, but it's not clear until we really run it. Okay, so it's called type inference. Is when we determine the type, it had to save until the runtime. Okay, so how that typing affect the way we write function? Okay, this one okay. So type inference. Let's look at type inference. Okay, type inference actually. Here we do have a function, integer argument 1, integer argument 2. So this one, if you declare it in some language such as Java, you know the type already, okay? But some of the language such as Python, you don't know. So like this one in JavaScript. So here we do have quark, bar, goodbye, and hello, okay? So there's a full function, there is a bar function, okay? So this one we do here we do have we will need to return variable to quark, okay? But we pass the goodbye and hello to there. So two string being used, and that's the function, and that's the function. That function is actually bar. So bar actually has these two functions, okay? But bar will call bool, but bar call bool by the parameter being swapped. So you need to swap the order, and then we pass the data type to full function. A full function C2 string, and it run the plus. The city plus becomes string concatenation. Not the so here if we put two numbers right now, it will be plus. But here we put two string, it will be doing string concatenation, and then the data type we propagate to the return type. Okay, and then we go back the return type, get the string type. Okay. So typing, okay, polymorphic mesh design, we can write a make list to replace this one, okay, and built-in function, language structure, and the operator to achieve polymorphism, okay. So here we can list this one, we can list this one with this one. So it can be a list, can be a tuple, can be a array of the set of the characters, okay. Okay, so this one is the for loop. Okay, for loop. For loop, you do put the iterable over there. Okay, any thing can be sequence or iterable can be put over there. Okay. So this one is also a polymorphic loop. Okay. Okay. We do have a make list. And make list we do create this and the item being put get and then put in there. So this item can be of tuple type or set type. Okay. But every time we get a item from that. So these items must be iterable. Okay. Okay, functional closure. Functional closure is an object that have polymorphic measure so that the object can be passed as parameter to generic function. Okay, so function closure is we can make a function a class to be called. Okay, we call it function closure. But because Python also support object-oriented programming, so function closure is not as important. Okay. So here we actually, so function closure is an object that which has polymorphic calculate method. Okay. And everybody can calculate. And we pass the object. Okay. We pass the object. Okay. Okay. And pass the object and to run it. Okay. So let's look at this one. Let's look at this one. It's called duck typing. Let me see. This one called duck typing 2. Okay, so this one we have zero calculator. Okay, you return zero. Square calculator. Okay, so these are different classes and they do have different way to do calculate. Okay. Okay, and then we do have function called run calculate. So run calculate will accept a data PO. Okay, this data PO and any starting value. Starting value is over here. Okay. So this one, you require a calculate. It should be a collection. Okay. So you call to function. Okay. Call to function, and then it has the calculate. Okay. Okay. So this each calculator in calculate. So this one actually is a list. Okay. This one has any. Okay. So it is require a parameter of the calculate, okay, and it has the name calculate in there, okay, calc there, okay, okay. So it actually wrong is different one. So let's run it, okay. So first one we do square calculate, okay, square calculate. Okay, so we pass through every single one and we do calculate and then we assign the current value, okay. And current value has a starting value as current value, and then we put the current value and then we put there one more time. So we do have 4, okay. 4 we pass into the square and that will become 16. And 16 pass to this square calculator again. So you do get 255, okay. So here we have bool actually pass to the length and length multiplied by 2, okay. So 3 and then you calculate get the length, that's 3 and then multiply by 2, you have 6. So next one we do nothing and 80, so 80 will be passed. Okay, so here this one is any function with the calculate name in there. Okay, so we can put this different name. Okay, so here we do have this one. Bool is the condition before that. Okay, so multiply by 3, so we'll repeat that 3 times. Because 3 times would be bool, 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 that would be 9. So the length would be 9. 9 squared would be 81. Okay, that's what we get here. Okay, so this one show you the function call. Okay, function call. You can apply this call to each function. Okay, and when we run, this run will take these things as the function. Okay, and that function will be passed as a parameter and then perform the calculate function for each one of these different object of the different type. Okay, so this is the end of the chapter 5b. Okay, we finished the object-oriented programming, and as you can see in the inheritance and the polymorphism part, Python is way easier than Java. Okay, because it determines the type at the runtime. But because of this, Python can be slower. Okay, can be slower. Okay, thank you and see you next time.